Welcome everybody, my name is Tim Sandy and I'm a VMware Systems Engineer. Today I'd like to discuss Virtualization 101 and how it relates to the VMware Hypervisor or ESXi. First of all, we need to talk about some of the common terms that you're going to hear in relation to server virtualization and especially with regards to VMware's hypervisor. So the vSphere Hypervisor or ESXi, as it's called, is VMware's operating system. This is the operating system that allows the capability for you to run multiple virtual machines on top of one single physical server. You'll also hear the term host. A host is just essentially is a physical server that has our hypervisor loaded on it and is running virtual machines. So that is simply what a host is. A virtual machine is just a virtualized computer. Now that can be either a computer running server or workstation OS. So it can be Microsoft server, Linux server, or maybe a Windows 7 desktop. It is a virtualized computer running on a ESX host. Resources is kind of a general term, and it usually references a virtual machine CPU or RAM memory. Just like it would on your physical desktop at your house. It's just virtualized and shared on a host. And then there's a data store. A data store is simply local or shared storage. It is essentially the same as your hard drive on your computer at home. And that is what a data store is. That's where all of the virtual machines files will be kept. In the past, we were used to a one-to-one relationship between our applications and our server hardware. And what I mean by that is, like the picture depicts here, is you have a physical server. We load an operating system on it, so say the Windows Server 2008 operating system, and then we would load an application on top of that. So there's this one-to-one relationship between the physical hardware and the operating system and the application. Now, the disadvantage to this is it wasn't very effective use of all your resources. For example, you might have a simple file server out there where between the processor and the RAM on it, on an average basis, day-to-day business operations with a company, that file server is only using about 30% of its CPU and RAM. Well, that's not really an effective use of all those resources, but there's really nothing you can do about it because of that one-to-one relationship. So you can't optimize, again, those resources. Now, in today's environment, we are now using virtualization. And with virtualization, what this does for us is it gives us this many-to-one relationship, unlike the traditional one that we just discussed, because now we have a physical server that we load the VMware hypervisor onto, which allows us to run multiple virtual machines on top of that. So now we have this many-to-one relationship between the applications, the virtual machines, and the hardware. With this, we have this term called density. Density just means that, okay, so for in this picture here, we're showing 6 virtual machines per physical host. So that density basically allows us to more effectively use those resources on that hardware. Now, we do have to be careful with density that we don't overload and have too many VMs on top of that physical hardware so that we're not overtasking those resources as well. But essentially, we're getting much better utilization out of those resources and better performance as well. Simply put, what virtualization does for us, and what seems to be very important to most people nowadays, is that it reduces costs for us. It saves us money. And it does this by the simple fact that now that we don't need as many physical servers, we're running multiple virtual servers on a single physical host. Because of this, we no longer need as many physical servers. And what goes along with that is it reduces the cost of maintenance for those physical servers because we have less. So less service, less parts for them. It also reduces the amount of IT staff that we need to manage those physical servers. That gets reduced as well. And of course, because now we are reducing the amount of physical servers, we require less space, we require less power to power those servers, and the cooling requirements for your data center also goes down as well because we have less physical boxes creating heat. Ultimately, it gives us better efficiency of our entire data center from a cost perspective, and it just gives us better management capabilities along with that efficiency. There's several key properties that make up a virtual machine. A virtual machine is essentially a set of files, and with that, we need to run them separately because we are running multiple virtual machines on top of one physical server. So we need to have partitioning between them. This allows us to run those multiple operating systems on one physical server. So we need to partition off those VMs appropriately. And with that, we need to make sure that they are very isolated, both from a fault and security aspect. We need to make sure that each one of those VMs are kind of run in their own separate container, and that there's no intermixing of the applications or the data between them. We need to make sure that they are stayed in a contained environment just for that one VM, and that all of the resources like the virtual CPU and RAM are dedicated to that one VM and not taken by another VM. So again, I said that these virtual machines are essentially files, which if you think about Windows Explorer on your Windows 7 desktop, you have a folder with several files in it. You can copy and paste them from one drive to another, from one folder to another. Since VMs are very much just made up of files, just like that on your Windows operating system, the great thing about that is they can be moved from one place to another. And it's much like copying and pasting from within your Windows Explorer. And we can also, by taking a copy of those files or a snapshot of those files, we can save a point-in-time state for those virtual machines as well. And the best thing is we have hardware independence when we're using our hypervisor, because we don't care about what the underlying hardware on those physical servers are. Doesn't matter if they've got different make and model brand network cards or hard drives or controller cards. It really doesn't matter. We don't care. So it's totally hardware agnostic. So when you're moving a virtual machine from one host to another, it doesn't care what that underlying hardware is. There are several core benefits to virtualization. We already talked about all the different various types of cost savings that it offers you because of less physical servers, less IT people, less power and cooling. It all comes down to a cost. So one of the aspects of these core benefits is obviously dramatically lowering costs. And that gives you the ability with that money savings to then allocate it towards something else, maybe new hardware, new software, whatever. It gives you the ability to reallocate that money that you're saving. It also reduces the complexity of the environment from an administrative standpoint, from a day-to-day operations to your normal maintenance that you have to do. You have a single pane of glass that you can manage both your physical and virtual environment from. You're no longer having to connect to each one of these servers to, say, do a bunch of patching. It's just easier from a day-to-day operation and maintenance standpoint, and there's less physical hardware that you have to maintain. And because it is virtualized, you can very quickly respond to business needs. You can basically deploy a new virtual server in the matter of minutes, whereas previously when we were all physical with that one-to-one physical server to application aspect, we would have to order a server, get it in, rack mount it, cable it up, load the operating system, load the applications. It took sometimes weeks or maybe even a month or two to deploy that, whereas now we're down to minutes with virtualization, which is a huge benefit. So there's some additional key features that we have when we start using virtualization. The first one that we're going to talk about is high availability, or HA. HA gives us the ability to proactively monitor our physical servers as well as our virtual servers or machines. And what it will do is it will detect if there's some sort of failure within a virtual machine. So for example, if your OS blue screens on you and it fails, well, it will detect that. And what HA will do is it will detect it. It will go ahead and do a restart of that virtual machine over onto another host. So that way it will automatically reboot it, bring it up on the other host, and there was no interaction that had to be done from the administrator. So it's going to do this very quickly, very efficiently, and it's also going to place it on a server and that's not overburdened, because when you start having automatic movement of virtual machines, you could obviously get a particular host that has a bunch of VMs on it where the other one's sitting there with very few on it, so the resources aren't evenly spread out. So when high availability kicks in, it will make sure that it appropriately puts that virtual machine on a ESX host that way it's better balanced for your resources across all your hosts in your entire virtualized environment. Another key feature that it uses when it is moving the virtual machines is VMotion. This gives you the ability to basically move a VM while it's up and running. Now, HA was more in a failure type situation where the VM had failed. It'll restart it on another host, where VMotion and live migration is talking about you have a VM where it is currently up and running, but let's say you need to do some maintenance on a particular ESX host. So you can use VMotion to move all those VMs over to another host, do the maintenance on that host, and then move the VMs back. So it gives you the ability to move a live server, but the biggest benefit is that it allows you to do that with no service interruption. So your users aren't going to see any interruption when you do that. Now with high availability, again, that's a failure situation. So you will see a little bit of an interruption when it gets started up over on to another host. But with VMotion, it will move it without any interruptions whatsoever. And in most cases, it does it in less than a minute. Virtualization also greatly improves our utilization of storage. If you think about the physical world again, the physical world, we would have a server that might have a 500 gig hard drive on it. The operating system in the application is only using, say, 100 gig of that 500. Well, essentially, you've got 400 gigs of space that's just sitting there not being utilized, and you really can't use it for anything other than what's on that local server. With virtualization, we have the data stores, and then when we build a virtual machine, we can tell it whether or not we want to thin or thick provision the drive associated to it. Now what that means is, if you think about a physical drive, you have a set dedicated amount of drive space. With thick provisioning, that's much of the same thing, where we're saying, okay, I am dedicating this 500 gigs, and so we're actually going to use 500 gigs of drive space out in our data store. With thin provisioning, what it does is if we only really need if we think we need about 100 gigs of data, we will go ahead and we will assign it 100 gigs thin provisioned. Now, the greatest thing about thin provisioning is that it allows it to dynamically expand. So if our need grows, our application starts to say has a database, and the database starts to grow as it naturally would, and our drive space requirement goes up, it will dynamically adjust the drive space as needed. So that is a huge benefit. So it keeps the server from crashing because it'll dynamically grow. But then again, if you think about the concept, instead of having to pre-allocate that 500 gigs for several virtual machines, we're telling it we only need 100. So now we're getting better efficiency and utilization of our hard drive space for our data stores. And we are now using smaller drives so that if we need to VMotion them or we need to back them up, it's a smaller drive, and it can accomplish those tasks much quicker. We talked a little bit just now about backing up. There is a couple different features in virtualization depending on what we're looking at. If you're talking about backing up, disaster recovery, they're very different situations. But just to kind of cover this topic a little bit, we have, first of all, snapshots. These are point-in-time snapshots, just like taking a picture with your camera. Snapshots are meant for only very short-term use. They are not a backup solution. But if, say, we need to do an operating system patch and we're not sure if that patch is going to possibly corrupt our operating system and cause problems with an application, we take a snapshot before we install it. We install the patch. We then see if everything is running fine. Then we go in after the fact and delete that snapshot. You don't want to keep those around for too long. Again, those are meant for very short term, but it's a great way for if you need to make some changes or do patching or anything like that. So snapshots are great for that. Now, in regards to actual backup solution, VMware has the vSphere Data Protection Advanced solution. This is an actual backup solution. It will take a snapshot of your entire VM, and you're going to use it much like any other backup solution. You are going to create backup schedules. You're going to have it maybe a weekly backup, a monthly backup. You're going to tell it what kind of retention period as to how long to keep it. And if you ever have an issue with a VM, you can then go into data protection and you can recover that VM, the entire OS and everything. So that entire virtual machine you'd be able to restore back to that point in time of the backup. Then we have some disaster recovery type tools. The first one being vSphere Replication. vSphere Replication is more of a manual method of disaster recovery. Now, disaster recovery, typically you have, say, two sites, and in the picture here you see site A and site B. With disaster recovery is a situation where site A may be our main site. It goes down. We want to be able to migrate our VMs out to site B so that our business can stay up and running along with our servers. So vSphere Replication will allow you to go ahead and replicate those VMs out to your alternate site or your DR site. Now, this is again a manual process. Now, with vCenter Site Recovery Manager, it does essentially the same thing. However, it does it in an automated fashion. You can go through and configure it to where it will literally migrate. If there's a failure at your main site, it will go ahead and replicate all your VMs that you've told it to out to your alternate DR site, and it'll do it in an automated fashion and can fail back. And it can do it all in a single click of a button. Whereas, again, vSphere Replication is a manual process of going back and forth. So just to kind of cover some of the backup and disaster recovery things that you can do with virtualization. This is a kind of a simple pictorial representation of what a VMware virtualized environment looks like. You have your three hosts, you have our VMware hypervisor loaded on them, and you have several VMs on each one of the hosts. And then that's all managed by the vCenter server, which gives you that centralized single pane of glass management. Here is some pictures that show what the Virtual Center looks like. Virtual Center has two different ways in which you can connect to it. The first one is a locally installed vCenter client. Again, you would install that, say, on your Windows 7 desktop, and you would connect up to your Virtual Center server using the local client application. Then they also have a web client where, using any browser, we can go out to the web client and we can also manage our Virtual Center environment. So this kind of gives you an idea, and if you look inside these, they look fairly similar between both the local client and the web client. As you will see your individual hosts. On this picture here, we got ESX 1, 2, and 3. And you'll also see a bunch of our virtual machines. Right now I'm clicked on the vCenter server virtual, and to the right you see that it shows you some of the different facts. It's a Windows 2008 R2 server, how many virtual CPUs, how much virtual RAM. It shows you IP information. It shows you a little bit of everything about that. And of course, there's several different tabs. You can look at resource allocation, performance. You can look at alarms. You can actually go to the Windows console and manage the virtual server from there. And it just gives you a single central management interface, again, from a local client and a web interface. So that kind of sums up what virtualization is, kind of how it's managed, some of the features of it. Hopefully this gives you a good basis of what server virtualization is like today using our VMware products. I hope everybody enjoyed this presentation, and hopefully you found it useful. And I thank you very much for watching the video. If you have any questions, please feel free to contact your local VMware sales and technical representative. Thank you very much, and have a wonderful day.